Okay, I also want to remind you about polynomials and how to add, subtract, multiply, and divide those. And then those rules, the rules of PEMDAS, like come over to this algebraic world. So, one, and we'll talk about this a lot, when we start to introduce polynomials, I really like to introduce a monomial first. Monomials have kind of three parts, so I'll give an example of one. So this is called a monomial. It has a coefficient. This number can be any real number. So like if that number changed to a third, that's fine. If that number changed to a decimal, that's fine. If that number changed to a negative fraction, that's fine, right? No problem, right? All of those are fine. This first number can be whatever I want it to be, and it doesn't have to involve the number 3. I'm just kind of using that. That's the coefficient. Okay. Then this is called the base of the monomial, right? The variable that you're using, and here's the exponent right there. This whole thing is typically called, when we use it in other places, a term. So when I expand this monomial and start to add, so polynomials, poly meaning more than one, and monomial, mono meaning one, right, are where I add and subtract, are created by adding and subtracting monomials. So as long as you have a bunch of monomials and you stick them together with addition and subtraction, this is called a polynomial. That's what I want to say. So an example, y'all have seen these, like let's say 5x squared minus 3x plus 2 is an example of a polynomial, right? Again, oh, I might make a real important distinction because I forgot something. This exponent here for monomials has to be a whole number, and it can be like 0, 1, 2, 3, 4, 5, 6, and on, right? It cannot be a negative number, so not monomials like 1/3 x to the minus 4 is not a monomial. Like it's another type of object. I'm not saying it's like disallowed. We absolutely work with things like this. It's just not a monomial. Does that make sense? Like that's not what this thing is. I'm trying to tell you like what is a monomial? Not this, but it is this. Is that okay? Okay. So when I come down here for polynomials, like not a polynomial would involve negative exponents. That's not a polynomial. Polynomials like 17x cubed plus 1/2 x squared minus 3x plus 0.1. That's a polynomial, no problem. So these coefficients can be a lot of different things, can be fractions or decimals, but over here also if I have a fraction like 3x to the 1/2 minus 2x, this, because it's not a whole number, is not a monomial, so this thing is not a polynomial. Okay. For polynomials, you probably remember that the biggest exponent, like here it's 3, is called the degree. So this is a degree 3 polynomial, right? We also typically write these in descending degree, so it's not a mistake or an accident that this is the degree here is 3, the degree here is 2, the degree here is 1. The degree of just numbers is 0. So the degree, this one I might make a note, when there's just an x, there's a hidden exponent of 1 that we don't write. So it's just hidden, we understand it to be 1, so the degree of this term is 1. The degree of constants, like here, this number 2 has degree 0, even though the whole polynomial, this whole polynomial has degree 2, because 2 is the highest exponent right there. Okay. So then we're going to talk about how to add and subtract polynomials. I'm going to give some reminders and then we'll do some multiplication as well. So the main thing that you need to remember for adding and subtract, is that we need to add and subtract like terms. So terms that are alike, so up here I'll say like this polynomial has 4 separate terms. 1, 2, 3, 4. It has 4 separate terms. So sometimes we'll have 2 different polynomials and the terms will be similar. So like terms, they have the same base and the same exponent. So let's say I have 3x cubed plus 5x, right? And that's one polynomial, and I'm going to add that to 2x squared minus 3x. Okay. So I'm going to remove these parentheses and add here. So I'll get 3x. I'm going to remove the parentheses. That would help if I did that. And then I'm going to look for like terms. So everything has a base, this base letter or variable of x. So that's the same. And so here when I start to do this, I'm looking for other terms that have an exponent of 3. There's nothing, so there's nothing to do, and I just write that guy down. Usually when people would do this, they would look for the next lower degree, so they would probably go to this one because it has degree 2. And I'll look for other terms that have degree 2. There are none. I get 2x squared. Now here, this negative 5x right here and this negative 3x are alike. They have the same base and they both have degree 1. So I can add those together. So I'm going to put them together right here just to talk about that. Then when I add those together, I really just do the operation with these coefficients. So in my head, I'm doing negative 5 minus 3, and then I'm going to put an x to the side. This is because we really think of this as factoring out. I mean, the reason this works is that I factor out the x. And we'll talk more about factoring, but it kind of comes out, and then I can just subtract these coefficients. So I get negative 8x, because when I subtract 2 negatives, they get more negative, right? So I get 3x cubed plus 2x squared minus 8x. And then this polynomial is as simple as it can be. There are no more like terms, so I can't do anything else. Okay, so let's do another example with addition and subtraction. And let's do a subtraction one. 2x squared minus 4x plus 5 minus negative x squared plus 9x minus 10. Okay. So, and the instructions here just usually say to add or simplify or something like that. Okay, the first thing I need to do is remove these parentheses so I can regroup like terms together. So I'm just going to rewrite this. So here's this first polynomial. Now, you have to be careful. One of the biggest mistakes, most common mistakes that people make when they're just working with polynomials is sign errors. It just happens over and over. So this negative gets distributed to each piece here. So this negative times a negative x squared should be a positive x squared. This negative times a plus 9 should be a minus 9x. And the negative times a negative 10 should be a plus 10. It'll change all of those signs in the second parentheses. So you have to be careful. Honestly, if you have trouble with this, it really helps to write these negatives in red. So like the way that I'm writing it is helpful. There's a reason I use color. Okay, now I'm going to regroup these like terms together. So I have this x squared in this one, this x and this one, and then the two constant terms, because they're just numbers, those are degree 0, right? So I'll just rewrite and then we'll add. It's 2x squared plus x squared. And then I have a minus 4x minus 9x. These signs are attached to the term that goes behind it. So if this is a minus, it stays attached to the 4. This minus stays attached to the 9. Plus 5 plus 10. And then I'm really thinking of these 3 problems that I have to kind of do because those are the like terms. So here's 2x squared, and then I have plus another x squared. There's a hidden one here that we don't write, but is really there. So this should be 2 copies of x squared plus another copy should be 3 copies of x squared. This is definitely still, just remember this, if you need to write in a 1, you can. This is a negative 4 minus 9 in my head. Negative 4 minus 9. Again, you should work on this computational stuff, but if you need to put this in your calculator, that should be a negative 13x. And this is a plus 5 plus 10 plus 15. And then that's done. There's nothing else to do here. There's no other like terms that I can add or subtract. Okay.